Now we're going to take a look at definite integrals, which is just another way of saying the fundamental theorem of calculus. Sometimes they say actually the first fundamental theorem of calculus because there's a second one. Right, so you're just going to make a tab. This is a listening check. Underline the title and put the title Fundamental Theorem of Calculus. And all that means is really finding the exact area under the curve. It's a definite integral, finding the exact area under the curve. Alright, in general terms, in official definitions, it's the integral from a to b of a function with respect to d of x is equal to the integrated function evaluated at b minus the integrated function evaluated at a, where capital F of x is the antiderivative of f of x. It's the antiderivative of f of x. Alright, so let's take a look at an example because this is really simple. Alright, the integral from 1 to 3 of x squared plus 2 with respect to dx. All you do is you integrate it. So that's going to give me x cubed over 3 plus 2x plus c. And the notation to write this so that you know to evaluate is a straight line down and goes from 1 to 3. So what it means is you plug 3 in first, then you subtract whatever you do when you plug 1 in. So let's plug in 3. So we're going to get 27 over 3 plus 6 over 3 plus c. And we're going to subtract when we plug in 1. So 1 cubed over 3 plus 2 times 1 plus, this is a listening check, color in example 1. Alright, so let's work that out. So that's going to be 27 divided by 3, which is 9, plus 6 plus c, minus 1 over 3 plus 2 plus c. Let's make all the denominators the same, or rather let's just make the numbers the same. 9 plus 6 is 15 plus c, minus, and making the denominator the same so we can add them, multiply top and bottom by 3, you're going to get 1 plus 6, which is 7 over 3 plus c. Alright, then let's get in the house or distribute. You're going to get 15 plus c minus 7 over 3 minus c. And you see how the c's go away? You technically don't have to put them in there, but we'll make a note of it in just a second. So make all denominators the same, multiply top and bottom by 3, that's 45 minus 7 is 38 over 3. And that's approximately equal to 12.66 repeated. Alright, so just a quick note, the c will always disappear in definite integrals, so there's no need to even put it. So from this example on, I'm not even going to put the c. Anytime you have a definite interval, so basically they tell you it goes from 1 to 3 or 5 to 6 or whatever it is, the c is just going to end up disappearing. Alright, so we're going to bring everything together we've done in the last 5 videos. We have an approximation for the function x squared plus 2 using left rectangles, using right rectangles, the average of both the left and right rectangles, the midpoint rectangles, and we just did the last video on the trapezoid rectangles. Now we found an exact value. So let's put in those values that we did from our previous note. From the left was 10.75. From the right was 14.75. This is a listening check. Go ahead and color in this whole approximation: left rectangle, right rectangle, average left and right, etc. The average of both of those is you just add them together and divide by 2. So 12.75, I'm sorry. From the midpoint, so when we did midpoint, we got 12.625. And the last video on trapezoids, we got 12.75. Right, so these are all the approximations for the same exact function. But when we evaluated it with the definite integral, we got 12.66. So the closest one to that seems to be the midpoint. So it looks like the midpoint, at least for this example, would have been the best approximation closest to the definite answer. Alright, so let's take a look at another example for definite integrals. So let's say from 0 to pi over 4 of secant squared x dx. So integrate that. The integral of secant squared is tan x, and we don't need to put the plus c again because remember the c is going to disappear. So from 0 to pi over 4. So again it says you evaluate for the top, which is pi over 4, tan of pi over 4 minus the bottom, tan of 0. Alright, tan of pi over 4, remember tan is sine over cosine. So I can rewrite that as sine of pi over 4 over cosine of pi over 4 minus sine of 0 over cosine of 0, and then evaluate that. So here's my little left hand or whatever, left fingers. Pi over 4 is 45 degrees, so that's going to be radical 2 over 2 for both. So radical 2 over 2 divided by radical 2 over 2. And then 0, that's going to be 1, 0. Cosine is first, so sine of 0 is 0 over 1. So it's 1 minus 0, which is equal to 1. So this is pretty straightforward. I mean, there's really nothing to it. Let's take a look at a little bit more of a difficult one, just because I'm not sure if you remember absolute value and what to do, so I just want to make sure I cover it. Alright, so remember absolute value has two functions depending on which side you're coming from. The first one's going to be negative, or the second one, which is positive. So just to kind of give you a rough idea, remember the absolute value is a v. And then we're going to subtract 1, which means we're going to move to the right one. So that's absolute value of x minus 1. And then we're going to shrink everything by, all the x values, by a half. So 1, that 1 is going to become a half. And then it's just going to be like a thinner v. Then I'm going to plug in some values. Let's see what happens when x equals 0, because that's where it starts. When x equals 0, you're going to get 0 minus 1, and the absolute value of that is going to be 1. When x equals 2, which is when my interval stops, you're going to get 4 minus 1, which is 3. The absolute value of 3 is also 3. So this is my interval, and we're finding the area underneath the curve. So I'm going to shade that in between the interval that I have. So it looks like the area for this curve is the area coming from the left, which is the negative version of it. So the integral of from 0 to 1/2 of negative 2x plus 1, just distributing the negative dx, plus the one from the right, which is the positive one. So it goes from 1/2 to 2 of 2x minus 1 with respect to dx. So go ahead and integrate that. We're going to get negative 2x squared over 2 plus x from 0 to 1/2. And then we're going to add the next integral, which will be 2x squared over 2 minus x from 1/2 to 2. Alright, so simplifying those 2's, or the 2's cross out top and bottom. Alright, so putting in the numbers. So let's put in 1/2. Negative 1/2 squared would be negative 1/4. Plus x, which is 1/2. Minus, and then we're going to put in 0 plus 0. And then on this side, you're going to get 4 minus 2. And then minus 1/4 minus 1/2. Let's make the denominators the same. So multiply top and bottom by 2. So now we're going to get negative 1 plus 2, which is positive 1 over 4. The zeros are going to go away. So plus, and then 4 minus 2 is 2. And then we're going to make the denominators the same. So multiply top and bottom by 2. Then you're going to have 1 minus 2, which is negative 1. So you're going to have minus negative 1 over 4, which is 1 over 4, and that's going to become a plus. And we're going to make the denominators the same again. That'll be 8 plus 1, which is 9. So 1 plus 9 over 4 is 10 over 4, which simplifies to 5 over 2. And literally, that's all there is to it. So this one is actually really quick and really easy. Let's practice.